All right, so we're going to look at solving one-step equations or one-step fraction equations with addition. So it's going to follow the same rules as one-step equations, except now we just have the fractions, so we have to take into account the rules for adding and subtracting fractions. Okay, so here we've got x plus 3/4 equals 11/2, or 11/12. So first step, we apply the additive inverse to the fraction that we're adding to the variable. And we're going to apply that to both sides. So 3/4, we're going to minus 3/4. 3/4 is the additive inverse of a positive 3/4. So we add that, or we subtract that as well to both sides. Okay, what's going to happen here is these are going to cancel out, leaving us with x on the left-hand side. And now we've got 11/12 minus 3/4. Okay, so the next step is we need a common denominator. So we're going to have to adjust these fractions. So the least common multiple of 12 and 4, that's going to be 12. So we only need to adjust one fraction, so that's x equals 11/12 minus, we're going to multiply this by 3, this by 3. That's going to give us 12 on the bottom, so we can have a common denominator. That's 9/12. Okay, now that we have that, we just add the numerators, keep the denominator. 11 minus 9 equals 2/12, and we can simplify that to 1/6. Okay, so that's all we're doing. We apply the additive inverse of the fraction, which is just the opposite of the fraction, to both sides. We isolate the x, then we just add our fractions. But before we add our fractions, we need a common denominator. Once we have a common denominator, we can add or subtract the numerators. Okay, another one. So we've got x minus 2/5 equals 9/10. So once again, we want to use the additive inverse of, now this is a minus 2/5, so it'd be a negative 2/5, so we want to add 2/5. Okay, 2/5, negative 2/5 plus 2/5 is going to be 0. What we do to one side, we have to do to the other. So we're going to add 2/5 on this side. Once again, on the left-hand side, we are left with x. So we've isolated the variable. On the right-hand side, we've got 9/10 plus 2/5. Okay, once again, we need a common denominator. So least common multiple of 5 and 10 is 10, so we're going to multiply the 2/5 by 2, both top and bottom. That's going to give us an equivalent fraction to 2/5, and yet we're going to have a common denominator. So now we've got 9/10 plus 4/10, and that's going to equal 13/10. Okay, so last step, we want to convert 13/10 into a mixed number. So denominator goes on the outside, numerator goes on the inside. Sorry, that's 13. Okay, 10 can go into 13 once. Remainder 3. This is our whole number. This is our numerator. And this is our denominator. So that's going to equal 1 and 3/10. Okay, so that one, we had the extra step of converting to a mixed number. All right, this last example, so we're going to do the same thing, except now we have mixed numbers. It's going to be the same for mixed numbers as it is for fractions, except we're going to have to convert them to improper fractions before we add. Okay, so we've got x plus 1 2/3. Additive inverse of 1 2/3 is going to be a minus 1 2/3. So there we've set it up. Once again, on this left-hand side, we're going to be left with x, because 1 2/3 minus 1 2/3 is going to give us 0. Leaves us with 2 4/9 minus 1 2/3. Okay, so you could subtract here the whole numbers and then the fractions. I'm going to convert them to improper fractions first and then solve. So 9 times 2 is going to be 18. 18 plus 4 is 22. So 22 ninths minus 3 times 1 is 3 plus 2 is 5/3. Okay, so now we've got them as improper fractions. We still need a common denominator. So the least common denominator, or least common multiple of 9 and 3 is going to be 9. So we multiply 5/3 by 3 over 3. Once again, it'll give us an equivalent fraction, but it'll also give us a common denominator. So this will be 22 ninths minus, and that would be 3 times 5 is 15. 3 times 3 is 9. Okay, so now all that's left is we have to subtract our numerators. 22 minus 15, that's going to give us 7. So x equals 7 ninths. Okay, so here it's already in a proper fraction, so we don't have to adjust it. If for any reason this comes out, our answer here were to come out as an improper fraction, we'd want to convert that into a mixed number. But that is how we go about solving equations, one-step equations with fractions with the additive inverse.